Okay, so here are some notes that you shall find in your packet. There is a dash here, but I don't want to do that because I think that could be falsely mistaken as negative volume. So instead of getting the dash there, if you could please cross that out and put it like this, that would make that less likely to happen. Okay, so when gas is expanding, that means the change in volume is positive, so volume is increasing. So work will be negative since work flows out of the system. When we're compressing a gas, the change in volume is negative, so volume decreases, so work will be positive value since work flows into the system. So this is just a correction to be made in your notes so that we don't have the dash there. Instead, we have the symbol here so that we're not representing this or confusing this as a negative. It's not negative in either case, it's just meant to be a statement. All right, so these are my standard pressures, which you've already written down on your card. And then we're going to skip this example. So 3A is the next example we're going to do. Calculate the final volume if original volume of gas is 28 milliliters at a constant external pressure of 15,230 millimeters of mercury. When the gas expanded, the work associated with the expansion was, 10,015 joules. Okay, so let's look at what we have here. Let's label what we have here in this problem. We have a pressure, we have an initial volume, and we have, based on the statement, we have work. So and it's asking us to find the final volume. So our formulas so far that we have used or learned about are E equals Q plus W, or change in E equals Q plus W, and work equals negative pressure delta V. So we have volume and need volume, so we can't use this one. We're going to have to use this one again. So we're going to say work equals negative P change in V. We're going to plug in what we have. It says negative 1015. Pardon me, it says expansion was 1015. Okay, so remember we said it's negative to expand, or it's negative when it expands, work is negative. So we're going to have negative 1,015 joules, that's my work, equals negative, because of the negative symbol there, pressure, which is 15,230 millimeters of mercury, times VF, which we don't know, minus VI, which is 28.0 milliliters. Okay, so when using this formula, I want to point out that you want to have your pressures always converted into ATM, your work always converted into liter atmospheres, and your volume always converted into liters. And that's because of the relationship between the fact that we know 1 liter atmosphere equals 101.3 joules. So we need to get a liter atmosphere, a volume, and a pressure converted into joules or vice versa to be able to do the calculations. Okay, so the first thing I'm going to do is look for conversions. I have work and it's in joules, so I need to convert that. So I'm going to go down here and I'm going to do that conversion. I'm going to take negative 1015. A reminder that this is negative because it said work expanded. It's negative for a waistband to expand. That's my little trick to help you remember. So we have 101.3 joules for every 1 liter atmospheres. So we're going to convert this into liter atmospheres. And we're going to get 3 sig figs. So then this is going to become negative 10.02 with sig figs liter atmospheres. Okay. I'm going to also look at my units of pressure and see that it's not in the proper unit. Remember, we want pressure in atmosphere, so I'm going to convert that. This was negative 10.02 liter atmospheres. I'm going to take my 15,230 millimeters of mercury and use my pressure conversions to say that there are 760 millimeters of mercury for every 1.00 ATM. So I'm going to take 7, let me try that again, 15,230, divide by 760, and I'm going to get times 1, and I can have 4 sig figs, so 20.04 ATM. So then I'm going to make this be 20.04 ATM. Okay. All right, and don't forget about that negative that's out there. This negative is still there. Okay. Let's make that negative the same color so it's not confusing there. So all we did was convert the joules into liter atmospheres, and we converted to millimeters mercury in ATM. All right, and we have to have volume in liters, so I got to convert that. All right, to remind myself, I'm going to do that over here. So I'm going to take 28.0 milliliters. Yeah, let's try that with an easier pen to read. Sorry about that. This does not, the pens do not stay the thinness like they're supposed to. So 28.0 milliliters, and we know there's 1,000 milliliters in a liter. So then we know that this is going to be 0.0280 liters. Okay. So that's that color. So this is going to become 0.0280 liters. And I've done the conversion. So I've done all 3 conversions. If maybe not all 3 were necessary, but I need to do all 3. So after I get all those conversions done, to be able to use this properly without having to worry about units, I get a clean answer, or work, I should say, of negative 10. Nope. Sorry, guys. Let's get a thinner marker. My handwriting's bad enough. So negative 10.02 liter atmospheres equals negative 20.04 atmospheres VF minus 0.0280 liters. Okay, so that's cleaning up what I've changed up here and converted. I'm going to get rid of the bottom piece just so that you guys can see the math that I'm going to do here. Let's get a bigger eraser and try to take care of this. Okay, so we're going to calculate this math here in just a moment. Okay, so just make sure you understand why I'm erasing how I went from the colored version to the solid blue. Just getting you to think about unit conversions there, right? Okay, so let's look at the math here now. Now, I know that some of you will want to distribute. That's what you're used to doing in math class, but there's no reason to do that, and actually it makes the problem more difficult. I can likewise just divide both sides by negative 20.04 ATM. Both sides, just thinking of basic algebra. So now this cancels with this, and atmospheres cancels with atmospheres. So we're going to do that math there on the left-hand side, 10.02 negative, divide by 20.04 negative, and I get 0.5000, if I'm thinking about that, liters equals VF minus 0.0280 liters. So now I'm going to solve for VF further by adding the 0.0280 liters to both sides. When I do that, we're going to get 0.5 plus 0.028, a value of 0.5280 liters equals my final volume. That's the end of that problem. Before we move off this problem, let's talk about the fact that it said that the gas expanded, right? So if it expanded, then that means volume went up. So let's see, did the volume in fact go up? We went from 0.028 liters to 0.528 liters. So yes, in fact, it did. So that makes sense that our math was set up correctly.